So in example 1, we looked at finding the particle's position at different times. We looked at finding the particle's position after 1 second. We looked at finding the particle's position after 2 seconds. Example 2, we're going to talk about what is the total distance that it traveled. We already have talked about how displacement is if I start here and I walk 1, 2, 3 paces, turn around, walk 1, 2, 3 places. I'm right back where I started. My displacement is 0. But the total distance that I traveled was not 0. I traveled 6 paces, 3 there, 3 back. So in this problem, same velocity function that we saw earlier, the same velocity function, we are going to, we're asking what is the total distance traveled in the 5 seconds that t is, because we said earlier that t was greater than 0 but less than or equal to 5, that this whole thing is a 5-second interval. And so again, the first part of it, the particle is moving. If we start here, if we started at 9, we said it was moving to the right, or to the left, and then it turned around and moved back to the right. And I think we figured out it finished at 35. But because it went from 9 to 35 doesn't mean that it went a total of 26 units, because it moved to the left and then backtracked a little bit. So how does this look using calculus? Well, what we can do, if we want to find the total distance traveled, really, we know that when we integrate this thing, if I look at the integral from 0 to 5 of t squared minus 8 over 1 plus t quantity squared dt. If I look at that integral, we know that that is this red area, which would be, that would be negative area, plus the black area, which would be positive area. And when I integrate this, it just gives me those two things combined, my negative number plus my positive number, which gave me, well, I can't even remember what we got out of that. But when we want to find the total distance traveled, it should make sense that the total distance traveled is just going to be equal to the integral from 0 to 5 of the absolute value of my velocity. Okay? It's going to be the absolute value of this thing. So it's going to take this little piece right here and basically turn it so that it looks like that. And so then that would become positive area. And we can go ahead and integrate. Now, to integrate this, I could find this point of intersection where it crosses my axis, integrate from 0 to that point, and then take the opposite of the area and then add from this point to 5. But really what we can just do is take out our calculators. I had mine sitting on my desk. So if I go math down to fint, type in my function, x squared minus 8 divided by quantity x plus 1 close parentheses squared, comma, integrate that with respect to x between 0 and 5, that should give me, I don't know if you can see that or not, but that would give me the integral. Actually, what I need to do is I need to put in the absolute value, don't I? I forgot to put in absolute value. So if I go second, insert, I'm just going to go to my catalog and get it, ABS, it puts in the absolute value of that. I need to close my parenthesis here, so second, insert, absolute value. I press enter, and it's thinking, and I got this is equal to 42.586, which actually makes sense. Right? 48.5826 seems like a pretty reasonable answer, considering at t equals 0, or at t equals 0, we know it's heading to the left, and it goes to the left about 5 to 10 or 5 units. Turns around, comes back 5 units. That's about 10. Then it went all the way out about another 30 units. So 42 sounds about right. So again, if you're talking about total distance traveled, you want the absolute value. If you're talking about displacement, then you're talking about just the regular integral. Okay? So this is total distance traveled. This would be my displacement. And the whole key here is that we are working with a velocity function. Okay, we're taking the integral of the velocity function.